Okay. Yeah, bottom edges are going to be part of the way to do it, but okay. So our value equals math.min r comma height minus r. Um, it's going to be a height minus r plus 1. Which means that that's going to be our value times 100 int r value. Run it now. I missed a semicolon somewhere. Okay. 4889. Okay. Let me just check. Oh, I don't need that window at all. (9021) minus 4889 is 4132. Now, yeah, I have approximately half the score I'm expecting to have. Hang on. That's not the button I wanted at all. No, 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 computer. Can I get rid of that calendar app so it doesn't come up when I do other stuff? Okay. So here we are. We have the sum is 9021 divided by 21. So we're expecting the boxes to be worth an average of 429 points. Okay. This is confusing me because, yeah, getting the thing right here. Yeah. It's 1 from the top edge, 5 from the left edge. And let's again look at 100 times 1 plus 5. So let's again look at how the GPS coordinate is calculated here. 100 times its distance from the top edge plus its distance from the left edge. So, but we might change that to 100 times its distance from the bottom edge to the closest edge. Okay. I'm currently in the interpretation problem phase of this, where I feel like I have got something wrong in my understanding of the problem, because I keep getting numbers that do not make sense to me. But yeah, there are 21 boxes here, which we've checked a couple of times, and it says that these boxes sum to 9021. None of the versions of this algorithm I've done sum to 9021. The only one that came close was the one that was kind of the worst. Um, oh, wait a minute. To the closest edge of the box in question. No, maybe? No, it's like to the edge of the map, to the closest edge of the box in question. I mean, is it still just top and left? Because that wasn't working earlier, but let's okay. Left will always be one of those. So, okay. Copying this. Let's try this in a slightly different algorithm here. All right. Get big value 2. Okay. So in this case, we go from height to there. We don't, our value is just R. And this entire second thing isn't needed because we go the whole way. $9,021. This is what I did first. How? Fine. Fine. I'm not gonna. I have no idea. I have no idea. Oh, I bet the first one failed because of like some kind of past run data pollution. And then I spent a whole bunch of time chasing down weird arguments. All right. Run all. It's got to find a whole lot of boxes for me. We have a number. Okay, I had the solution a while ago, and I badly popped myself away from it. Okay, we're gonna save. We're gonna commit. Day 15. Add. Commit. All right. It is 5 o'clock now. Let me just check in here. I'm going to take a quick break to check whether I need to stop streaming. I'm just going to go check in with my spouse because this is a bit longer than I normally take at this phase of things. I want to see what he's up to. So I will be back in a minute. Either we'll wrap the stream then or we'll keep going. But yeah, I'll be back in just a few moments. All right, that is my confirmation that I do not need to be anywhere else. You know, that important thing of not completely bailing on your spouse by running over on stream time a lot. But now that I've confirmed I'm not, let's go ahead and hope that day 16 goes a bit better. Close day 15, back over to here, pop the template open, Control Shift S, save it as day 16. And here we go. .NET Interactive, please don't have trouble figuring out your hints. Find your thing there. Great. All right, day 16, not day 1. Reindeer Maze. It's time again for the Reindeer Olympics. This year, the big event is the Reindeer Maze, where the reindeer compete for the lowest score. You and the historians arrive to search for the chief right as the event's about to start. It wouldn't hurt to watch little, right? The reindeer start on the start tile marked S, facing east, and need to reach the end tile marked E. They can move forward one tile at a time, increasing their score by 1 point, but never into a wall. They can also rotate clockwise or counterclockwise 90 degrees at a time, increasing their score by 1,000 points. To figure out the best place to sit, you start by grabbing a map from a nearby kiosk. For example, okay, there are many paths to this maze, but taking any of the best paths will incur a score of only 70, 36, total 36 steps forward, and turning 90 degrees a total of 7 times. Okay, The best path in one very 90 returns the very first move, rotating the reindeer facing east to facing north. Analyze your map carefully. What is the lowest score a reindeer could possibly get? Okay. So here we go. This is the all right. We have example data 1. All right. And I'm going to go ahead and hang on here. Can I copy cell, paste cell, example data 2. Now they're giving me more example data. We're reaching a point where I probably want to start using it. And then let's get the real data. Okay. All right. So we've got now 3 data sets. Let's go ahead. We can collapse our data here. And let's just also add here. Yeah. Partial data 1 is example data 1. And then partial data 2 is example data 2. And we'll use partial data 1 to start with. Okay. So run all. We've got this, and now the first thing we want to do is let's go back to yesterday's code, because our map parser is going to be useful again. All right. Let's see. Our data just looks like that. So, all right, again, we're going to want direction, we're going to want step, we're going to want coordinate. So we're just going to grab ourselves pieces we've built in the past. All right. We import coordinates. We have the direction enum. We have the step thing. And then, I mean, I think we just, yeah, our string map. There's that, and then this. Okay. So here we go. So let's do this here in a step 1 up here in a parser thing here. All right. Data.split on n, and our initial map is that. All right. Let's run that. Great. Let's run that. Great. Okay, so we've got some useful prereqs in here. Now, I think, okay, we want to find the start and the end. So we've got a decent way to find a start. We have, let's just go ahead here and coord. Find symbol, car map, comma, car, symbol, equals symbol. We're going to return those coordinates, and r less than map.length, c less than map sub r dot length. Great. So now we have a find symbol function, which will find us a symbol. All right. So now, more stuff to do. More fun things. Let's go ahead and say, okay, so this is a search algorithm. From any given position, we want to find the best way that we can get to that position, which is basically going to be the cheapest move that we can make. So, all right. And let's just go ahead and say, yeah, int so yeah, best possible score involves, I mean, Yeah, I'm just kind of thinking here about, yeah, the best possible score to get from A to B. Uh, Chord start, start facing, chord end. Okay, so our best possible score to get from start facing to end, um, to get from somewhere to somewhere. Okay, okay. So, I mean, I kind of end up thinking about working backwards from valid end states, where if we're at the end state, we could be on the end position in any configuration. If we are, I mean, yeah, is this DP? Um, because yeah, from any cell, we can say the best way to get there. Yeah, the best possible way to get to the end is given a from a given coordinate and facing. You can make one move, yeah, which takes you to something else, and then, I mean, do I seriously just kind of flood fill this thing with because yeah, at any given point in time we can just start the best possible score for end is 0. You're already there in any facing. Then yeah, the best possible score to get to any other cell is from, yeah, to get to there is, yeah, any other cell that can get there is from 1 in the facing with it. Not every cell is sensible, but yeah. I mean, yeah, okay. Let's say so this is going to be uh dictionary on so this is a dictionary on coord on tuple of coordinate direction to int. Okay. Okay, so now I've got a new dictionary. Actually, and I think let's just throw that in here into best possible score. All right. So now what we want to ask is for everything here, we're going to say um, mm, and actually, let's go ahead and give ourselves a quick thing here. Using position equals coord C direction D. So this dictionary uses position and int, and again we're going to say from position start to coord end. Okay, and yeah, we do not care what the facing is at the end tile. Yep. Okay, great. So now, yep, priority queue of position, comma, int, positions to evaluate equals new. All right, so we have this dictionary of the best value we've seen at each position. Or yeah, best value seen. All right, and positions to evaluate. So what we just want to do is we're basically going to throw into the queue every position that we might need to do. So we start, we're going to work backwards from the end because we know what the score is at the end. So we can say best value seen dot add. Actually, hang on. Yeah. For each. Actually, we'll just do, yeah, no. Best value seen dot add end, comma, direction dot up. And, oh yeah, comma, 0. It takes no points to get there. All right, best value seen, add end, direction up, 0. Up, down, left, right. Okay. So here we go. For any given position, the best value we see is the one where we come into it like that. Okay. Now, we're then going to say actually, what I do kind of want to set these up here. So it's really going to be so yeah, list position, end positions equals there's probably a cute little way of doing this that uses less copying and pasting, but honestly, copying and pasting 4 things is faster for me than remembering the best way to zip iterators together. So there we go. All right, and now what we want to do is we need to say, yeah, for each var p in end positions, best value dot add p0. Okay, but we've also got that list of all those positions because we need to basically, from each of those, we need to put in evaluation of how to get there. So what we want to do is we want to say, okay, we're going to look at a position and we're going to say position P. No, right. End P there. So we aren't overusing P there. So position P equals end positions dot first. This is just a quick little hack to get something in there. Okay. So what we want to do is for every position, we need to go find the neighbors. So actually, I guess here what we want to do is we want to say, yeah, there are 4 ways to get to this position. Yeah, and you can turn 90 degrees in either direction. So, all right. So if we came there by going forward, then it's going to be P equal, just taking a position. All right. List a position. And actually, this is going to be a list of, yeah, position, comma, int from positions. Position current. All right. So what we want to do here is, yeah, if, okay, we need the map here. All right, we have initial map. So, all right, position start, coordinate end. All right, we also need double car array map. That's also important. All right. So we can again say car map at coord C is map sub c.r c.c. Okay. Swap out to some different music. We'll go back to the Lorelei. It's been since the start of streams for that. Okay. So here we go. We have the from positions. Now, if so list position int result is a blank list. All right. If current dot, so we have, we have current dot p, dot c. That's the coordinates. Actually, you know what? We haven't done that yet. No, it's going to be p position. So if the current position, and I'm going to need, I need the vector, which is going to be, so that's going to be, what is that? Coord vector equals, and we've done, yeah, we did that before as well here. Let's just go grab that. Yep, the step in the direction. Do I have the steps there? Yes, we do. Actually, here. Let's just go ahead and slightly change this thing here. Let's just write direction, or sorry, coord vector for direction D is going to be the step in the int D. That's all. Run that. Great. All right. So now we can say if the current position and we have add on our coordinates, but we don't have subtract. So let's just go over here and add that to the thing we're using. Add a b a r minus br ac minus bc, because that will make it easier to do these in reverse. Okay. So now we're going to say if, yeah, if subtract current P vector current D, that'll get me a vector, right. Oh, hang on, we need to just rerun all. Okay. So if map at subtract current P vector current D is a dot, we can get there. So that means then result dot add current P vector current D, and